So first we want to understand what it is that Aristotle is investigating. So Aristotle, the ancient Greek, born around 384 BC and died around 321 BC. Aristotle is trying to understand a lot of things. Aristotle is a master at so many different fields. He's interested in so many different things. He was, of course, known in the medieval world for his logical reasoning. Aristotle's known as the father of logical reasoning. Here we have Aristotle, but we're going to focus on Aristotle and his physics. Okay, physics. Now, at its most basic, physics is the study of motion, how things move. I can hold up this small piece of wood, for example, and if I let go of it, I can predict that it will fall until something stops it. And it does. So the question is, how does this move? But in the study of natural philosophy, because we really shouldn't be using the word science at this point. The birth of modern science comes a bit later. In part, that's what's being born in what some historians call the scientific revolution. So at this point, we should really call it natural philosophy. It's the study of nature, but through philosophical terms. So what does that mean? It means that you're not just asking how does something move, but you're asking why it moves that way. And in order to have a complete answer, you have to be able to predict the how and explain the why at the same time. That's going to be kind of a fundamental break that we'll talk about when it comes to the birth of modern science. But natural philosophers are concerned with the philosophy of nature. So Aristotle is concerned with what makes up the universe, and he's also concerned with movements. For example, why does this fall? And why does it fall in a straight line? Aristotle believes that what we see around us in the world is made up of 4 elements. There is a 5th element, a heavenly element, an element that does not exist here on earth. That element is ether. So these are the 4 sub-lunar elements. The 4 sub-lunar elements. You have your heavy elements, earth and water. And then you have your light elements, air and fire. Now, what distinguishes heavy elements from light elements is the fact that heavy elements have a natural motion, what he describes as a rectilinear motion, meaning a straight line motion that moves from high to low, whereas light elements have a rectilinear motion that moves from low to high. So, for example, earth is the heaviest of the elements. Therefore, earth will always seek the center in a straight line towards the center. Water is also a heavy element, so it will seek the center, but water is not as heavy as earth. And therefore, the water would sit on top of the earth, which is why we could go to a lake and see the earth underneath the water and the water sitting on top. Now, air travels, it's a light element, so it travels from low to high, meaning that if air is trapped under the water, we might see this pocket or this bubble of air bubble to the surface because air wishes to sit on top. Now, I just used a word there, wishes to sit. It is not a conscious movement. Aristotle is not claiming that they are alive, but they do have a natural place. Fire is also a light element because it moves from low to high as the flames are moving through the air. So, Aristotle believes that you can take any object, a piece of wood, a mug, and you can essentially recognize that those objects are made up of combinations of the 4 elements. And yes, when we say elements, we are referring to it in the same way that we would use kind of the word elements today, the building blocks of everything. Now, of course, today we have the periodic table of the elements, and we actually break those down into protons, neutrons, and electrons, and scientists are even going into the subatomic with quarks and things like that. But for Aristotle, the farthest down that you could go into essentially matter would be these 4 elements, at least in the sublunar world. Now, ether was the heavenly element, and what distinguished ether or the heavenly element from the sublunar elements is the fact that ether traveled in a circle. On Earth, things moved in a straight line. They had rectilinear motion. But looking at the sun, the moon, and the stars, Aristotle saw circular movements. So therefore, the things of the heavens could not be made of the same things that made up what's on Earth, because their motion was completely different. And what Aristotle was defining these elements as was based on their motion. So Earth, for example, is that element which travels from high to low and is the heaviest and therefore makes its way towards the center. Water is that which travels from high to low towards the center, but is not as heavy as Earth. Air is that which travels from low to high, finding its natural place just above the water. And fire is that which travels from low to high and finds its natural place just above the air. It doesn't mean that fire continues off into space. They have their natural places. And so a diagram of their natural places would look something like this. And there are certain consequences of a theory like this. For example, if these are the natural places, then, well, we should be underwater. But of course, we're not. So how can Aristotle explain that we are not underwater? And the answer is that there is such thing as violent motion. I can throw something up into the air, but the reason it comes back down is because of its natural place. But there are violent motions that take place. For example, if fire is trapped under the ground, it might displace the grounds as it tries to rise up. And so there are certain answers that Aristotle is able to have that still fit with his overall paradigm, his overall philosophy of nature and of movements. And there's a couple of other very interesting consequences. The shape of what the Earth, the planet, should actually look like, as well as its motion. Well, if heavy elements are seeking the center, what does that mean? Well, it means the center of the universe. And so, therefore, the place of Earth must be at the center of the universe, and it must be not moving. It must be immobile. Why? Because if the Earth were moving, then that would mean that the heavy elements are being pulled or are moving towards a natural place that's somewhere other than the center. And it's a moving target. And that doesn't make a lot of sense for Aristotle. And it doesn't make a lot of sense in regards to essentially this theory, if you will, this paradigm, this explanation, this philosophy that he has created when it comes to the four elements, their motion, and why things move the way they do. And so Aristotle has to recognize this, and he says, okay, so it's moving towards the center, and therefore the logical conclusion, and remember, Aristotle is a master of logic, the logical conclusion is that the Earth must be in the center of the universe, and it must be immobile. The other consequence of this is the idea of the shape of the Earth. Now, it is, for some reason, popularly taught that up until about 1492, when Columbus set sail, people thought that the Earth was flat. But that doesn't actually make sense if you think about what Aristotle is saying here. Aristotle is saying that every piece, every particle of Earth is trying to travel towards the center as close as it can get to the center, which means that it cannot be a flat plane, but rather the Earth must be a sphere. In fact, it must be a perfect sphere. And so the idea that people thought the Earth was flat, that idea is just wrong. Anybody who told you that they thought the Earth was flat up until, say, 1500, they're wrong.
Find a few examples of early medieval texts that suggest a flat Earth, but they are few and far between.
Educated individuals who had rediscovered Aristotle recognized through his logic that it made sense that the Earth could be no other shape but a sphere. And the point is, nobody thought the Earth was flat. Nobody thought that. They all knew that the Earth had to be a sphere. And so educated individuals in the 12th century could explain why the Earth had to be a sphere. And it was built not on belief per se, but on the idea that the logic makes sense. And if you begin with these premises that Aristotle is describing, then the logic makes sense. The earth has to be spherical and it has to be immobile.
There's another interesting consequence of Aristotle's ideas, and it is that the heavier an object is, the faster it must fall. And so if you were to drop a hammer and a feather, the hammer is heavier, and so therefore it would fall much faster than the feather. And of course, according to Aristotle, this makes sense. His observation, which is such an important part of his theories, it makes sense that heavier objects are falling faster. Now, today we know that this is not actually the case because we can test the fact that a hammer and a feather can be dropped in a vacuum where there is no air resistance and show that they actually fall at a constant rate.
How about that?
But it illustrates how for Aristotle, there was quite an importance placed on observation.
Aristotle was probably aware of some of the teachings of Eudoxus, who taught around 365 BC. And Eudoxus describes these spheres, these concentric spheres, which Aristotle sees as essentially rigid, but impenetrable. And so these spheres are moving in concentric circles around each other, creating what Pythagoras and others refer to as the universal music, the music of the spheres.
And it was something that Aristotle rejected because Aristotle recognized that loud sounds would shatter solid objects. And these spheres of ether in the heavens shatter, according to Aristotle, because this is what he is observing.
Think about this music of the spheres, and we think about this center place of the earth, and we think about all of these things. There's a lot that actually would be attractive to, say, a 12th century scholar in Europe who's devoted to the Christian worldview, but is recognizing some of the genius, if you will, of the ancients. And so, for example, when Aristotle talks about the first immovable mover, this is an idea that made perfect sense to the 12th century scholars who are creating this synthesis, because they can easily see this first immovable mover as the Christian God, these other immovable movers as angels. Thus, the angels are pushing these concentric spheres around a circle. Now, we then put the earth at the center of this universe. And so with the earth at the center of this universe, man, God's most special creation, being placed into the center, illuminates that special position.
When it comes to this universal music, this music of the spheres, or this harmony of the spheres, the 12th century Christians may have been aware that Aristotle had rejected this idea that the Pythagoreans were pushing, but ultimately they were able to create a synthesis where it was not an audible music, but was still nonetheless a beautiful example of God's perfection. That God had made humanity and put humans at the center of the universe and created this vast universe around them that played the mathematical symphony that God orchestrated and God enjoyed.